Today's video will look at the derivatives of inverse trig functions. The first one we'll look at is y equals sine inverse x. Well, if y equals sine inverse x, that means sine y should equal x. Because if you have sine y equals x, to undo the sine, you would do inverse sine of both sides, and that's what would give you y equals sine inverse x. So the reason we're going to write it like this is because those are things that we know the derivative for. So the function we're working with is y equals inverse sine x. By writing it like that, we'll now use implicit differentiation. Well, the derivative of sine y would just be cos y times y prime. And the derivative of x is just 1. So therefore, y prime is equal to 1 over cos y. But we want to try and get our derivative, our y prime, in terms of x. So what we'll use is we'll use one of our Pythagorean properties. We know sine squared y plus cos squared y should equal 1. Subtracting the sine squared y over, we get cos squared y equals 1 minus sine squared y. And then taking the square root, we've got that cos y is equal to the square root of 1 minus sine squared y. So we'll replace cos y with the square root of 1 minus sine squared y. Now, the reason we did not need the plus and minus in our square root, we had defined originally that y was between negative pi over 2 and pi over 2. Well, that's like negative 90 and 90. And using your ASTC, cosine is positive in both those quadrants. So that's why we did not need the plus and minus, because we were only working with those specific y values. So we've got y prime equals 1 over the square root of 1 minus sine squared y. But we still don't have our derivative in terms of x. But we know that sine y is just equal to x. So we're going to write this as y prime equals 1 over the square root of 1 minus. Since sine y is just x, it'll be 1 minus x squared. And that is our rule for the derivative of inverse sine. 1 over the square root of 1 minus x squared. Well, let's see if we can do it for tan x. If we want to find the derivative of y equals inverse tan x, keep in mind, just like before, that means tan y is equal to x, because this is something we could take the derivative of. Derivative of tan y will be secant squared y times y prime. Derivative of x is 1. We'll divide by secant squared y. That'll tell us y prime is equal 1 over secant squared y. And we'll go back to our Pythagorean properties. We know sine squared y plus cos squared y is equal to 1. If we want a secant squared, that means a cos has to be in the bottom. So divide everything by cos squared y. That'll give us tan squared y plus 1 equals secant squared y. So we can now replace the secant squared y in the denominator with tan squared y plus 1. Now, usually, you're going to see the 1 come first in the formula we'll eventually get. So I'm just going to write it that way as well. So we'll have 1 over 1 plus tan squared y. In reality, you could do it either way in the denominator. Just usually you see the formula written with the 1 first. So just like before, we do not yet have our derivative in terms of x. But we know that tan y is just equal to x. So therefore, this is really just 1 over 1 plus x squared, and that's because tan y was equal to x. Therefore, our derivative of inverse tan x is just 1 over 1 plus x squared. So let's see if we can use this in a problem. We want to do the derivative of 1 over inverse sine x. Well, we've got a quotient, so we'll just do quotient rule. So y prime is equal to low, d high, derivative of 1 is 0, minus high, d low. Well, we just saw our derivative of inverse sine x is 1 over square root of 1 minus x squared, all over low, low. So you could leave it right like this. That's perfectly fine. If all they want is the derivative, we'll just see what it looks like when we neaten it up. So we'll have a negative, after this all wipes out, we'll have negative 1 over square root of 1 minus x squared, all over sine inverse x squared. And because dividing by sine inverse x squared is like multiplying by 1 over sine inverse x squared, this will really just simplify to square root of 1 minus x squared times sine inverse x squared. Okay, but again, you could have left it, oops, and this should have a minus there. Okay, but again, you could have left it like our original up here if you wanted. We'll look at another one, x times arctan square root of x. Arctan, same thing as inverse tan, just if they give you arctan, make sure you continue writing it as arctan throughout the problem. We've got a product rule here. This is really x times arctan square root of x. So we'll do derivative of the first, which is 1, times regular of the second, arctan square root x, plus, because it's product rule, regular of the first times derivative of the second. Well, our regular rule for arctan would be 1 over 1 plus x squared. But because we don't have a plain old x, where the x is, we need to put in a square root of x. So this is really going to be 1 over 1 plus square root of x squared, because this is essentially chain rule. We don't have a plain old x inside our function. Because it's chain rule, we now need to multiply by the derivative of the inside. Well, our inside was the square root of x, so that'll be 1/2 x to the negative 1/2. And that's coming from the fact that square root of x can be written as x to the 1/2. So again, it's perfectly fine to leave your answer like this. If you want to neaten it up, we can write this as arctan square root of x. In our numerator, we would end up with just an x to the 1/2. The reason being, you have an x to the first and an x to the negative 1/2, giving you an x to the positive 1/2. All over, we would have a 2 on the bottom, and we would have a 1 plus x squared. Now, the 2, or sorry, just 1 plus x, because it's square root of x squared. Okay, the 2 would have to stay outside the parentheses because it'd have to multiply both parts, and you could distribute the 2 through if you wanted. But again, you could just leave your answer like we have it in green there. That would be perfectly fine as well. Now, the two main ones we're going to use are inverse sine and inverse tan. Okay, those you'll be expected to know for quizzes and tests and everything. The other ones may come up in homework problems, though, and maybe on a problem set, things where you can use your notes. So here are those other ones. Again, the 2 starred are the ones you need to have memorized. Our inverse cos is just the negation of the inverse sine one. Inverse secant, we've got 1 over x times square root of x squared minus 1. And then similar, that sine and cos are just negations of each other. The cosecant inverse is just the negation of that. And inverse cotangent is just the negation of the inverse tan one. So just to show you where one of these more complicated ones comes from, we're going to derive the inverse cosecant one to finish out the video. So we'll take y equals inverse cosecant x, and just like the other ones, we'll write that as cosecant y is equal to x. Well, cosecant y is just 1 over sine y. So that means that 1 is equal to x times sine y, or 1 over x is equal to sine y. Well, we'll now come over here and we'll take the derivative of that. 1 over x, think of that as x to the negative 1. So our derivative will be negative 1 times x to the negative 2, which we will write as negative 1 over x squared. That's the derivative of our left. Derivative of sine y would be cos y times y prime. And our goal is to find out what y prime is, so we'll divide the cos y over. And dividing by cos y is like multiplying by 1 over cos y, so we'll end up with negative 1 over x squared times cos y. We want our derivative in terms of x, though, so we've got to substitute in for the cos y. We'll again use our Pythagorean property that sine squared y plus cos squared y is equal to 1. Getting cos y by itself, we'll have cos y is equal to 1 minus sine squared y, all under a square root. So this means we'll have negative 1 over x squared times the square root of 1 minus sine squared y equal to y prime. We still haven't gotten rid of the y yet, but we know from over here that sine y is just 1 over x. So we'll now have negative 1 over x squared square root of 1 minus 1 over x squared equals y prime. This will become negative 1 over x squared square root of 1 minus 1 over x squared equals y prime. And all we're doing now is we're doing a little algebra to neaten it up to make it look just like it is on the formula sheet. Technically, either of these green answers are equivalent. We just want to show that it's the same thing we just wrote down on the previous slide. So we'll get a common denominator under our radical. That means that this is x squared over x squared, giving us x squared minus 1 over x squared. That's equal to y prime. Well, this means we have negative 1 over x squared times square root of x squared minus 1 over square root of x squared is just x. And one final step to make it match what we had on our previous slide. We have an x squared and an x that can cancel, so it'll give us negative 1 over x times square root of x squared minus 1. And that matches up with what we wrote for the derivative of inverse cosecant on the previous slide. That's all for this video. We'll see you next class period.